Welcome back to our Chapter 1 Limits and Continuity video discussion. And now we are going to talk about the last topic for Chapter 1, which is the limits of some transcendental functions. Our objective is to evaluate limits of some transcendental functions. We have trigonometric, exponential, and logarithmic. Transcendental functions define to be the functions that are not algebraic are as important as algebraic functions. That is why we devote this section, this discussion, to look into the limits of some transcendental functions, namely trigonometric, exponential, and logarithmic functions. Just like the previous lessons, we can also use graphical and tabular methods in finding the limits of such functions. However, we focus our attention on using easier but more accurate ways of finding those limits. That is by using established results or theorems. We also take advantage of the fact that the basic forms of the said transcendental functions are continuous at every point of their respective domains. So we know in our previous topics, we talked about domains and range. And now, take note, ang transcendental functions are continuous at every point of their respective domains. Tatong isgutan paglawom later. We have the limits of trigonometric functions. Definition 1.8.1, the following are the 6 basic circular functions and their domains. We will start at sine. F of x is equal to sine x, where x is an element of real number. Next, cosine. F of x equals cosine x, where x is an element of a real number. Cosecant. F of x equals cosecant x, where x is an element of a real number, minus k times pi, such that k is an element of an integer. Second, f of x equals secant x, where x is an element of a real number, minus 2k plus 1 times r times pi rather, all over 2, such that k is an element of an integer. Tangent f of x equals tangent x, where x is an element of r, real number, minus k times pi, such that k is an element of an integer. And last, cotangent. F of x equals cotangent x, where x is an element of a real number, minus 2k plus 1 times pi all over 2, such that k is an element of an integer. Theorem 1.8.1, the sine, cosine, secant, cosecant, tangent, and cotangent functions are, take note, continuous at every point in their respective domains. So they are continuous at every point in the respective domain. So this theorem has a significant impact when it comes to finding the limits of transcendental functions. We have theorem 1.8.2. Let A be contained in the domain of the function whose limit is being evaluated. So let's talk about limit. First, limit of sine x as x approaches A equals sine A. So yung x, ang result niya sa limit of sine x, yung value ng A. So gipulihan ra ang x sa A. Kung unsa ang nadiha approaches to, that will be our value for sine. Pero, pag x lang, okay, take note. only x. If you have y, then y, z. Number 2, limit of cosine x as x approaches a equals cosine a. Then, limit of secant x as x approaches a equals secant a. Limit of cosecant x as x approaches a equals cosecant a. Limit of tangent x as x approaches a equals tangent a. And the last one is limit of cotangent x as x approaches a equals cotangent a. So, timan-an nato ang theorem 1.8.2. So, let's have some example. Evaluate limit 2 sine x all over square root of 3 secant x minus the square of cotangent x as x approaches pi over 6. So here we have limit of 2 sine x over square root of 3 secant x minus the square of cotangent x as x approaches pi over 6. So, ito tagsa-tagsaon. So, equals limit. So, here we know that is 2 sine x. That is can be written as limit of 2 as x approaches pi over 6 times limit of sine x as x approaches pi over 6 all over limit of square root of 3 as x approaches pi over 6 times limit of secant x as x approaches pi over 6 minus, take note we have the square. So we got limit of cotangent x as x approaches pi over 6. Okay, that is the square. Alright. So now let's apply the theorem sa limit theorem. So limit of 2 as x approaches pi over 6, that is 2. Limit of sine x as x approaches pi over 6, that is, according to the theorem na itong gisgutan ganina, sine x, that is equivalent to sine a. Our a is pi over 6, so we have sine pi over 6. All over. Limit of square root of 3 as x approaches pi over 6, that is square root of 3 times limit of secant x as x approaches pi over 6, that is secant pi over 6 minus the square of limit of cotangent x as x approaches pi over 6, that is cotangent pi over 6, the square of cotangent pi over 6. Okay. So now we have 2 times. So what will happen to sine pi over 6? So we need to apply the trigonometric function. We know that pi over 6, if you are going to convert this one, that is sine 30 degrees. So ang sine pi over 6, if you are going to check the circle, it was discussed during our pre-calculus, sine pi over 6, ang iyang result is 1/2. Tanawon lang nato sa table, tapos dun sa table makita nato pag 30 degrees, then sine pi over 6, that is 30 degrees. So na-equivalent dito, which is 1/2. So always check with those tables. So matter gamiton ari. So that is the value of sine pi over 6. That is 1/2. So square root of 3. Now, secant pi over 6 o secant 30 degrees. The equivalent dun is 2 over square root of 3 minus the cotangent pi over 6. Equivalent doon is square root of 3. 2 times 1/2, that is 1. And then, square root of 3 times 2 over square root of 3. I think that is 2. 2 minus the square of square root of 3. So that is 3. So 1 over 2 minus 3, negative 1. So the answer is negative 1. So that is the limit of 2 sine x all over square root of 3, second x minus the square of cotangent x as x approaches pi over 6. The answer is negative 1. Okay? Sa kung balikon, importante nga makabalo ka sa theorem, the limit theorems, plus kabalo ta sa value sa sine pi over 6. Familiarize the table, then dapat kabalo ta unsaon pag-solve. We are going to manipulate, we are going to give the correct evaluations or simplification of given numbers. Next, we have theorem 1.8.3. Number 1, limit of sine x over x as x approaches 0 equals 1. So kani nga theorem para ni sa mga result nga 0 over 0 nga gitawag na tog indeterminate form. So we have limit of sine x over x as x approaches 0 equals 1. Number 2, limit of 1 minus cosine x all over x as x approaches 0 equals 0. So ito na siyang i-apply. So we have 3 examples. Atong tagsa-tagsaon. The first one, evaluate each given limit if it exists. Number 1, or letter A, limit of 3 sine 2x all over x as x approaches 0. So, take note ang A na to ha, 0. So, then, kani nga forma, pag inana gani ang mga pormahan, so man ang yang limit. Letter A, limit of 3 sine 2x over x as x approaches 0. So, unang buhaton nato is unsaon nato nga kaning sine 2x magka 2x punta diri para makuha nato ang kaning nga theorem 1.8.3 sine x over x. So, let nato nga ang atong x diri is 2x. So, sa ibuhaton nato i-multiplyan na nato og unsa may kuwang sa x dire para magka 2x is 2. So, multiplyan nato og 2 over 2. So, we got limit 3 sine 2x over x times 2 over 2 as x approaches 0. So, ang 2 over 2, that is a technique. Actually, ang 2 over 2, that is only equals 1. And ang purpose lang nato is kaning atong x dire magka 2 para magkapareha na sila dire nga 2x. Kay i-let nato nga atong x is 2x. Okay? So, we get limit. So, 2 times 3, we get 6 sine 2x over 2x as x approaches 0. So, next, we have limit of 6 as x approaches 0 times limit of sine 2x over 2x as x approaches 0. Take note that limit of 6 as x approaches 0 is 6 times limit of sine 2x over 2x as x approaches 0. Diba? Let na to x is 2x. So that is sine x over x na. And that is equal to 1. Diba? X approaches 0. Ma-apply na to ni nga theorem. So we get 1. So 6 times 1, 6. So that is the limit of 3 sine 2x over x as x approaches 0. 6. Letter B, limit of cosine x minus 1 all over 2 sine x as x approaches 0. So, kaning numerator, anggid siya sa ikaduha, 1 minus cosine x. So, atong buhaton, atong parihason si numerator. Ngayon nani. So, atong buhaton equals limit, diba? Negative 1 plus cosine x. If you are going to rearrange it 2 sine x as x approaches 0. Then, kay 1 minus cosine x man to, i-remove na to ang negative. So, get 1 minus cosine x over 2 sine x as x approaches 0. Okay? So, para di maglimog, tanggalan na to, iuna na to si negative. 1 minus cosine x as all over 2 sine x as x approaches 0. So, next, we have here 1 minus cosine x. Pero atong denominator, di man kapareha sa theorem, which is x. So, unsay buhaton nato aron magka-x ang 1 minus cosine x. Ato i-multiply ang numerator o denominator og 1 over x para ang atong 1 minus cosine x natay x sa denominator niya. So, we got limit. So, 1 minus cosine x times 1 over x over 2 sine x times 1 over x as x approaches 0 equals limit of 1 minus cosine x over x over 2 sine x over x as x approaches 0. So, ang atong numerator karon na natay limit of 1, ang klarohon, limit of 1 minus cosine x over x as x approaches 0 over limit of 2 sine x over x as x approaches 0. So, atong numerator ron, kapareha na siya og forma diri. 1 minus cosine x over x, in which ang limit ana is 0. Equals. So, 0 ta sa ibabaw. Ari sa ubos, we got limit of 2. Para mas klaro, as x approaches 0 times limit of sine x over x as x approaches 0 equals 0 over limit of 2, 2 times limit of sine x over x as x approaches 0. That is our first theorem, which is equal to 1. 1. So we got 0 over 2 equals 0. So the limit of cosine x minus 1 over 2 sine x as x approaches 0 is 0. Letter C. Limit of cotangent x sine 2x as x approaches 0. So diri, atong buhaton aron magamit ato ang theorem 1.8.3 is we are going to use trigonometric identities for cotangent sine. Limit of cotangent x sine 2x as x approaches 0. So, we are going to apply trigonometric identities para magamit natin theorem 1.8.3. We get limit. We know that cotangent x, that is equivalent to 1 over tangent x, right? So, we got 1 over tangent x times sine 2x as x approaches 0. So we got limit 1 times sine 2x, so sine 2x over tangent x as x approaches 0. Ang tangent x, ang iya pong identity, that is sine x over cosine x. So equals limit of sine 2x over sine x over cosine x as x approaches 0. Next, equals limit of sine 2x over sine x times 1 over cosine x. So, pwede rin nato na siya Separate, di ba? Next. So, here at the top, we have 2x. So, unsa may ato i-multiply sa numerator o denominator. So, ato i-let here nga atong i-multiply is 1 over 2x. 1 over 2x over 1 over 2x. Limit of sine 2x times 1 over 2x all over sine x times 1 over cosine x times 1 over 2x as x approaches 0. So we get limit of sine 2x over 2x as x approaches 0 all over limit of sine x over 2x times 1 over cosine x as x approaches 0. Okay, here sine 2x over 2x, the answer with that is the first theorem here, which is equal to 1. Our x is 2x, right? So we have 1 over limit of sine x over 2x. Para x lang po diri sa ubos, tanggalon na to si 1 half. So we got limit of, ito ipakita, aron tayo maglibog. Tapos, limit of sine x over x as x approaches 0. And then, limit of 1 over cosine x as x approaches 0. So we get 1 over limit of 1 half, times limit of sine x over x, another 1, times limit of 1 over cosine x, that is 1 over cosine 0, equals 1 over 1 half times 1, that is 1 half, and 1 over cosine 0 is 1. If you are going to trace using the table, the answer is 1. So we got equals 1 over 1 half. So the final answer is 2. So limit of cosine x sine 2x as x approaches 0 is 2. So medyo taas ang process. That's why you need to apply theorems, limit theorems. You need to apply identities and the table also to get the final answer. Now we have the limits of exponential and logarithmic functions. Definition 1.8.2. Let b is greater than 0. So it can be 1 pataas. Pero ang b na to must not equal to 0, 1 rather. So it will start from 2 up. The exponential function with base b is defined by f of x equals b to the power of x where atong x is an element of a real number. So ang b na to pwede 2 up basta greater than 0 basta dili equal sa 1. Atong x must be a real number. The logarithmic function is the inverse of the exponential function. So ang binali sa exponential function si logarithmic function. This is our definition 1.8.3. Let b is greater than 0. Ang diripod, ang b dapat dili equal sa 0. Ang sa exponential dili equal sa 1. The logarithmic function with base b is defined by f of x equals to logarithm of x with the base b, where our x is an element of an open interval 0 and positive infinity. So that is to the right sa 0 in between the two. If the value of b is equal to e or Euler's number, the function defined f of x is equal to e to the power of x. Is called the natural exponential function. Its inverse, kaya pong binali is natural logarithmic function, which is the ln. So defined by f of x equals ln x. Muna binali sa Euler's number. So the basic exponential and logarithmic function The same with trigonometric, are continuous at every point in the respective domain. Theorem 1.8.5, let b is greater than 0 and must not be equal to 1. So it will start at 2. Limit of b power of x as x approaches a is equal to the power of a. So ang x na to, pulihan na to sa value sa a. And limit of logarithm of x with the base of b as x approaches a is equal to logarithm of a, ang x gipulihan sa a with the base b, provided that our a is greater than 0. Can be 1 above, more than. Alright. So we have the example. Limit of 1 plus e to the power of x plus 1 all over square root of 2x minus logarithm of x squared with the base of 2 as x approaches 2. So medyo lisod tan-aon pero dapat atong tagsa-tagsaon to solve using the following theorems nga atong gibasa ganina. So first equals limit of 1 plus e to the power of x plus 1 over square root of 2x as x approaches to 2 minus limit of logarithm x squared with the base of 2 as x approaches 2. So, para ato na pagkadzong klaruhon, we got limit of 1 as x approaches 2 plus limit of e to the power of x plus 1 as x approaches to 2, tapos limit of square root of 2x as x approaches to 2 minus limit of logarithm of x squared with the base of 2 as x approaches 2 equals. Now what is the limit of 1 as x approaches to 2? That is 1 plus the limit of e to the power of x plus 1 as x approaches to 2. We know that is a Euler's number. Ato lang pulihan diri ang x, which is the value of our a, which is 2. So we got e to the power of 2 plus 1. According to the theorem, pulihan lang ang x, the value of 2. And then limit of square root of 2x as x approaches to 2. That is square root of 2 times 2. So ang value sa atong x, pulihan na nato sa atong a. Minus, we have logarithm of x squared to the base of 2 as x approaches to 2. So we got logarithm of what is our a? According to the theorem, ang x pulihan na sa a. So we have 2 squared to the base of 2 equals 1 plus e to the power of 2 plus 1, 3 over square root of 4 minus logarithm of 4 to the base of 2 equals 1 plus e to the power of 3. Square root of 4 is 2, diba? Minus logarithm of 4 to the base of 2, which is 2. Then, get the LCD. 2. So, 1 plus e to the power of 3 minus 4. E to the power of 3 minus 4 plus 1. Ato lang i-duol ang like terms. So, we got e to the power of 3 minus 3 over 2. Okay? So, negative 4 plus 1, that is negative 3. So, the limit of 1 plus e to the power of x plus 1 over square root of 2x minus logarithm of x squared to the base of 2 as x approaches to 2 is e to the power of 3 minus 3 all over 2. So, ato lang i-apply ang kaninga theorem. Okay? And also the definition. Okay? So, that's it for our limits of some transcendental functions. Always remember to familiarize the given theorems and definition, and also the trigonometric identities and other identities.